Dear friends, hello and welcome today at Airbus. We are in Toulouse for the Airbus Summit, 2 days dedicated to aeronautical and defense innovation here directly in Toulouse. Behind me, it's the 3.2 and XLR. Let's tour the store from here to directly see the best innovations. And we start with Ecopulse. Behind me, you can see a distributed propulsion system with 6 small electric motors spread across the entire wing. This creates thinner, more efficient planes with a new generation of more relevant devices. You have electric propulsion because we are with small electric motors, and you have a kind of electric generator inside. So here too, we are moving forward with generations that are more efficient, lighter, less polluting, obviously always safer. We also have work that has been done on noise. If we synchronize the propellers, will it allow us to reduce the sound footprint we will have on the ground? And the last element, an incredible thing, they will address the asymmetric thrust by reducing power on the left engines and increasing it on the right engines. It's like paddling a canoe or kayak on only one side. You'll turn to the other side. He suggests having planes without rudders, using asymmetric thrust instead. Inside Ecopulse, you have a gigantic battery. Well, it's there, 800 volts instead of 28 volts as we usually have in aviation. Usually in planes, it's nickel-cadmium batteries. This one, it's lithium-ion. Here we have the new generation. It's solid and much smaller, which is interesting. You can make the comparison with the size that it takes up on traditional batteries. With the next generation of solid batteries, we will reach 400 Wh per kg. That is to say, we are roughly reaching the limits from which aviation can be electrified. It will start with small models, we will adapt, it will require work, but in the end, solid batteries are more compact and it allows to be more modular as well. The new engines make the planes more efficient and the condensers can be distributed throughout the fuselage rather than condensing them all in one place. And here, look, this is what we call the open rotor. It's a work that is done with CFM, which is a joint venture between General Electric and Safran, the open rotor. The goal is to have a fan that will be even larger than the previous planes and the generation of planes that is coming. Arrive? By 2035, we hope to save about 25% of fuel efficiency, half of which would come from engines with this new generation. Logically, we know how to model, we know how to check with wind tunnels if it works, but it has to be tested in real life. So in 2028, they are going to mount it on an A380 that will serve as a flying test strip to check if there are really the same performances once in flight, what we had observed in theory. And then like that, for 2035, we might have planes with even bigger, even more eco-friendly engines. We go back outside and we find the A321XLR. It's a revolutionary plane. Until now, when we had to make flights that lasted 10 to 12 hours. Wide-body planes were essential for crossing the Atlantic or vacationing in Thailand. With 2 aisles inside, we carried 300 to 400 passengers simultaneously. That means if you were from Toulouse and you wanted to go to New York, logically your plane could not be profitable. So what did Airbus do? They made Evolure A321, which is a particularly efficient plane. They reorganized the interior, they pushed the walls to be able to put additional tanks. This enables the plane to make extended flights with only 220 passengers, for instance. The first one was delivered last November to Iberia, which allows for transatlantic flights from secondary cities to North America. By making a stopover, we reduce necessary consumption by 30–40% since stopovers significantly increase consumption. So it's a more efficient, greener, more direct plane. We save time. It's good for everyone. It's because it has no competition, as Boeing couldn't evolve its 737 to achieve the same efficiency. And traditional companies that only worked with Boeing, like Qantas, they bought 321 XLRs to replace the entire fleet of medium-haul aircraft with Airbus. So this is really one of the planes that explains the very good health and the very, very full order book from Airbus at the moment. Bravo, Airbus. Friends, you know that Airbus are also the champions of atmospheric carbon dioxide capture. In front of me is a module that was used by the International Space Station in the past. Essentially, we capture and trap the carbon dioxide. This also allows us to export Airbus's internal technology to earn carbon credits. That is, you put a system like this, a little bigger, and then you will be able to transform again. 5 tons, 250 tons for the largest carbon dioxide modules per year, just to store them. And like that, we recover atmospheric carbon dioxide potentially to make fuel again. Like that, it makes a closed cycle. Planes are eco-friendly in terms of carbon dioxide emissions, but noise pollution remains an issue. minus 75% for the latest generations of devices with, in fact, different phases of flight. On landing, 60% of the noise is aerodynamic. It's the whistling of airflows around the landing gear, wings, etc. So there's a lot of work in this area. On takeoff, 80% of the noise comes from the engines. Significant developments, especially in twin-flow engines, are addressing this issue. In this context, the cold air will surround the hot air, it makes less noise inside, and you also have the interior lining of the reactor. Who's going to trap the noise? That reduces the ground noise. Do you remember when we went with Jonathan to see a truck plane some time ago?
A truck plane flight simulator priced at $350 is visible just in front.
If you remember. So, has it progressed since the last time we spoke?
We've conducted 150 hours of testing on the Optibus, also known as the Opti unit. We're now on the truck and have moved on to our completed 350 direct current. Yes, there are 394 yards SN. And we started to do some taxiing, testing the anti-collision and various systems on our direct current plane directly.
That means there's the up-next intelligence, the light detection and ranging sensors, and everything we saw at the time.
Yes, well, not all. We selected the best, what we thought were the most relevant, and now we're testing them on our plane and at the airport at the same time. We even did more. We tested the 350 with the Optibus also behind to be able to also exchange data and see what one sees.
The other sees it too. Data transfer and tactical data fusion are bringing us closer to fighter plane technology. There is also the issue of decarbonizing the industry. What material will we use? Very light composite, but which does not withstand heat. Aluminum, also very light. It has replaced much of the titanium, but titanium is even lighter. Steel, I assure you, is the heaviest. Inconel is a material that can withstand extremely high temperatures. We are using additive manufacturing, which is essentially 3D printing with metals. Only a few millimeters remain to scrape on both the right and left sides. Usually we would have a gigantic block of metal that we would have to machine with. 90% of the material will be lost because it will simply be waste, it will be hot, it will consume water, it will consume electricity. In this case, we will reduce part production by 70%, saving 30-40% of material. On the other hand, we move on to composite metals. There's another real question, what do we do with it? It's officially recyclable, that's thermoplastic. There you see, it's to make a small access hatch, for example, next to the air intakes on the engines. Composites are also recyclable. Do you remember X-Wing, the up-next Airbus project, in which they wanted to make a much thinner, much more efficient wing? Which also compensates for turbulence using LiDARs, etc. I refer you to the video to see the complete project. That's it, the first piece of wing is here. That's just this little piece right there, that's it. They started cutting the wings in view of that in installation to make a high-performance plane. And here we see the deformable aileron. Look closely. With your new materials, we can do crazy stuff. And even downwards. It's crazy, isn't it? The other advantage is the small hinge here. And it goes to 90 degrees. This allows, on a full-scale plane, connections of 2.50 meters. In a future 2035 version, we envision integrating this technology into a device. We will be able to stay with a plane that has much longer wings, while being in the category of less than 36 meters. That is the same operating category as an Airbus A320. Airbus is also about space and service. You know the Pleiad Neo satellites with 30 centimeters of precision, the Spot satellites with 1 meter of precision, well, all of that. You have a tremendous amount of applications. For instance, it will be agriculture. Ensure plantations are eco-friendly, with no deforestation or land clearing for palm oil production. Also, check that the replantings we do, for example in carbon offsetting, are not dying of thirst. At the time I was working at COGIC, the Interministerial Crisis Management Center, and there is a satellite charter, in which authorities can request the help of all observation satellite operators to take aerial photos. For instance, the MH70 is used to assess damage following natural disasters, which is another service provided by Airbus. Friends, I hope you enjoyed it. I'll see you very soon for new videos with Airbus. And then, if you want to innovate, you know which door you have to knock on.